New Glenn's first flight delays, NASA announces new plans to bring Martian rocks to Earth, but Rocket Lab thinks they can do better, Webb sees some very distant stars, and Astra makes progress on its next rocket. We'll have all that and a whole lot more this week in Spaceflight. NASA has evaluated its options for the Mars sample return mission and came up with some new plans that will cut the costs nearly in half and get the mission done years earlier. Sounds amazing, doesn't it? Well, not everyone seems happy with the new plans. Why? Well, it's a long and fascinating story, so hold on tight. NASA has been planning a mission to bring Martian rock and sediment samples back to Earth for a long time. In fact, it's already started the first phase, as the Perseverance rover has been collecting samples since it arrived on the Red Planet in early 2021. NASA collaborated with the European Space Agency to design a mission to retrieve these samples and bring them back to our home planet. As time went on, the mission got more and more expensive, and the date when the samples were supposed to arrive on Earth got pushed back further and further. But in April of last year, NASA had finally had enough and decided to reevaluate, because at that point, the mission was projected to cost $11 billion, and the samples wouldn't even arrive in the hands of scientists before the year 2040. Here's what NASA Administrator Bill Nelson thought of it.
Well, that was just simply unacceptable. It was my decision that, in consultation with everyone, we pulled the plug on it.
So NASA asked the space industry for proposals, reevaluating almost every part of the mission, and this week, Nelson presented two new options for the next administration to consider. The new plans are much cheaper, with costs estimated between $5.8 billion and $7.7 billion, and what's more, they could deliver the samples to Earth by 2035. The first option is a new mission plan that uses proven technology that NASA's used before, in particular, the Sky crane that was used to deliver Curiosity and Perseverance to the Martian surface. The Sky crane first descends under a parachute, then hovers above the surface under rocket power before slowly lowering the payload under tethers so that it touches down softly. This is what previously allowed NASA to land those heavy rovers without any airbags. But the lander for the original Mars sample return mission was too heavy, way heavier than the Sky crane could even handle. So NASA had to develop a new and untested landing system, which of course added to the costs. The new mission plans require a lighter lander, which means that the Sky crane is back on the table, but it'll still be 20% heavier than the Sky crane for Perseverance, and this mission would cost between $6.6 billion and $7.7 billion. The second option hands over the task of landing on Mars to a commercial partner. Nelson mentioned that SpaceX and Blue Origin have both shown interest, but that other companies could also be considered. If a commercial partner provides the lander, the mission costs would range between $5.8 billion and $7.1 billion. Both options dramatically alter almost every part of the original plan. For instance, either landing system would require a newly redesigned landing platform, and instead of solar panels, the new lander will be outfitted with the radioisotope thermoelectric generator, which is a small nuclear reactor. This will allow the lander to operate through Martian dust storms, which reduces mission complexity. Originally, the sample canisters were set to be cleaned in Martian orbit for backward planetary protection, to make sure that the samples won't accidentally bring extraterrestrial microbes or other contamination home to Earth, however unlikely that may be. The new mission plans redesign the sample loader to perform this task on Mars, and once cleaned, the samples will be loaded into the Mars Ascent Vehicle, the rocket that will launch the samples into Martian orbit ahead of their journey to Earth. From there, we get to what's pretty much the only part of the mission that hasn't changed. The samples will still travel to Earth in ESA's return vehicle. NASA even considered the option to deliver the samples to cislunar space instead of directly to Earth, but decided against it as it required a separate mission to then retrieve the samples from lunar orbit. So if NASA wants to bring all 30 samples collected by Percy to our planet by 2035, the agency needs to choose one of these two options by 2026. The remaining time would then be used to further research the requirements for the commercial option. But regardless, this will only work if NASA gets the funding. The agency needs at least $300 million for this mission in the current fiscal year, otherwise the sample delivery could be delayed until 2039. Associate Administrator Nikki Fox emphasized the importance of getting the samples back as soon as possible.
So the Mars Sample Return Program remains the next step for us to be able to study samples from the planet Mars. It's humanity's first mission to bring scientific samples from any planet right back here to Earth for study using our state-of-the-art facilities.
But will this actually be the first mission to return samples from Mars? Well, even if the new plans play out exactly as NASA hopes, China might still beat NASA to it. The country plans to launch its Tianwen-3 mission to the Red Planet in 2028, and if that mission succeeds, Chinese scientists might be able to study samples as early as 2031. That's way earlier than NASA can currently dream of. Of course, this is a completely different mission though. Percy has allowed scientists to collect very specific samples, but the Tianwen-3 mission will only be able to collect a sample at its landing location. This means that NASA samples will likely have much more scientific value than the Chinese ones, but only one can be the first to bring back Martian rocks. Now remember how I said not everyone was happy with NASA's new plans? Well, Rocket Lab thinks that it can do better, and that NASA made the wrong decision. Rocket Lab wants to get Percy's samples, quote, in the hands of scientists faster and more affordably. And the company believes that they can do it as early as 2031 and for less than $4 billion. While most people don't think about Rocket Lab as a company with much experience in designing interplanetary missions, it might actually have what it takes. The many companies that Rocket Lab has acquired over the years have worked on recent Mars missions. And with that collective experience, Rocket Lab has designed a mission of its own. If NASA wants to go for this mission, they'll have to put a lot of trust into a single company. Not only that, they'll also have to abandon their collaboration with the European Space Agency. But it might just help them to be the first to bring a piece of Mars back to Earth. And if they want to be the first, they'll have to make this very important decision very soon. Nelson believes the new plans will set NASA up for success.
I think it was a responsible thing to do, not to hand the new administration just one alternative if they want to have a Mars sample return, which I can't imagine that they don't. I don't think we want the only sample return coming back on a Chinese spacecraft. And that's just simply a grab and go kind of mission, whereas ours has been a very methodical process. So I think that the administration will certainly conclude that they want to proceed. So what we wanted to do was to give them the best possible options.
Regardless of which option NASA's new administration decides to go with, we'll get to look forward to a very exciting mission. And of course, we'll cover it all for you as it happens right here on This Week in Spaceflight. And hey, if you want to follow along with us, there should be a subscribe button somewhere nearby, and oh, hey, I think I see a like button as well. And now we'll take a glimpse at some other stories across space, starting with the Indian Space Research Organization, or ISRO, which has postponed the docking test of its SpaceX mission. SpaceX, which is short for Space Docking Experiment, launched in late December to test the docking mechanism for India's Gaganyaan human spaceflight program. The docking test was originally scheduled for January 7th and then was postponed 2 days so that ISRO could run more ground simulations in the event of an abort scenario. Ahead of the docking attempt on the 9th, the agency commanded one of the spacecraft to move closer to the other, but as it turned out, it had drifted more than they expected, so the attempt was aborted. ISRO has since managed to get the spacecraft under control and is now planning another docking attempt soon. Another mission that launched alongside SpaceX has seen more success though. This week, ISRO posted a time-lapse of cowpea plants growing on board the Compact Research Module for Orbital Plant Studies, or CROPS spacecraft. CROPS simulates an Earth-like growing environment, albeit one at 0G. Another tower is rising at Kennedy Space Center. NASA contractor Bechtel is working on the Mobile Launcher 2 for NASA's SLS rocket, and this week the company stacked the first segment of the umbilical tower. Now confusingly, this first segment is actually called Module 4, and it's the first of 7 making up the tower. The new launch platform is needed to accommodate the slightly taller SLS Block 1B, which is set to launch for the first time in 2028 on the Artemis 4 mission. Mobile Launcher 2 is slightly taller and more beefed up at the bottom to accommodate the larger loads of the heavier SLS Block 1B. NASA previously decided that it wasn't worth upgrading the existing tower, as that would take too long and delay Artemis 4. Last year, a NASA report found that the new launcher might not be ready in time anyway, and that costs had spiraled out of control. NASA reached an important milestone with its Nancy Grace Roman Space Telescope. Technicians have joined the telescope and its 2 instruments to the spacecraft in the clean room at NASA's Goddard Space Flight Center. Engineers will now begin an extensive testing campaign to ensure that the telescope works as expected and that all systems function as intended. Then the spacecraft will be subjected to environmental tests to make sure that it can withstand the extreme environments of launch and space. Additionally, the tests will ensure that the spacecraft and the rocket will not interfere with each other's communications. Later this year, the telescope will be outfitted with its solar panels and aperture cover. It's still on track for completion by fall of 2026, when it'll finally be ready for its mission to answer questions about dark energy, infrared astrophysics, and exoplanets. Roman's launch is currently scheduled for no later than May of 2027. Astra is still working on its next rocket, known as Rocket 4. This week, the company shared a photo of Rocket 4's upper stage tank as it was sent off for qualification testing. During these tests, the company wants to verify that the tank can handle the loads and stresses of launch. The rocket's first stage tank completed similar testing this past summer. Now, if you've been following spaceflight for a while, you'll notice that we haven't heard from Astra for a very long time. The company hasn't had the success that it hoped for with its previous rocket, as 5 out of the 7 launches ended in failure. One of them literally went sideways. After the last failure in June 2022, Astra moved on to Rocket 4, but dwindling finances meant that the company had to downsize significantly. With only a small team, the company went private last year. But from this week's update, it seems that the company is still going and planning to launch a rocket at some point in the future. We don't know when, but we'll tell you all about it whenever it happens. The James Webb Space Telescope has captured images of more than 40 individual stars in a galaxy far, far away. The galaxy is nearly 6.5 billion light-years from Earth, which is so far away that its light has been traveling towards us for half of the universe's existence. At these distances, the light emitted by stars in a galaxy usually blends into a smudge, which makes it impossible to see individual stars. Yet, Webb was able to observe 40 of them, more than ever before. So how did it do it? Well, Webb is known for its exquisite resolution, but it needed a little help to see those stars. That help came from the dark matter in galaxy clusters located between the distant galaxy and Earth. The mass from these clusters bends the light from the galaxies behind them and acts like a lens. Astronomers call this effect gravitational lensing, and it can magnify a galaxy by 100 times. However, that wasn't enough for Webb to see those stars. The astronomers got lucky, as some stars in the galaxy cluster also happened to line up just right. They added to the gravitational magnification of the entire cluster, which magnified the light of individual stars in the distant galaxy. This lucky alignment provided enough magnification for Webb to resolve these faraway stars individually. Another impressive achievement. This telescope just never ceases to amaze. The American defense company Kratos received a $1.45 billion contract from the U.S. Department of Defense to lead the MACH-TB 2.0 program. That's short for the Multi-Service Advanced Capability Hypersonic Testbed 2.0. As the name implies, the program aims to test defense technology on hypersonic test flights. Kratos is collaborating with several other companies to work on the project, and among those are a few names that you might be familiar with. Rocket Lab will provide some launches with HASTE, the suborbital variant of the company's Electron rocket. Firefly Aerospace also seems to be working on a suborbital variant of its Alpha rocket, as they announced that it will also provide flight test capacity for Kratos. Additionally, ABL Space Systems is part of the team. The company recently withdrew its RS-1 rocket from the commercial launch market to focus on defense missions. And Stratolaunch was also announced as a partner for the MACH-TB 2.0 program, which might not be a surprise given that the company is working on an air-launched hypersonic test vehicle called Talon A. With all of these and more companies contracted for this program, it seems we'll get many more suborbital launches in the future. If only they weren't so secretive, it'd actually be cool to see them. This week, devastating wildfires raged in the Los Angeles area, and thousands of people were ordered to evacuate their homes. As the fires destroyed entire neighborhoods and their infrastructure, SpaceX announced that Starlink and T-Mobile have enabled texting through the Starlink direct-to-cell satellites so that people in the area can receive emergency alerts and text loved ones and other emergency services. All of us here at NSF hope that those in the LA area remain safe and have a quick and resilient recovery. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. The first launch of the year took flight on January 4th. At 1:27 UTC, a Falcon 9 lifted off from Florida carrying a communications satellite for the United Arab Emirates-based company Space 42. Falcon delivered the satellite into a geostationary transfer orbit, and from there, it'll take several months to reach its operational geostationary orbit. Once operational, the satellite is set to provide communications across Africa, Europe, Central Asia, and the Middle East. The booster for this mission was B-1073, which flew for the 20th time. It ended its mission by successfully touching down on the deck of SpaceX's drone ship, a shortfall of gravitas. For the next mission, we go to China, where a Changzheng 3B launched on January 6th at 20 UTC. This was the 555th flight of the Changzheng or Long March series of rockets. The payload on this mission, Shijian-25, was placed into a geostationary transfer orbit. This satellite's main mission is to test technology for refueling other satellites and extending their lives. Back in Florida, another Falcon 9 launched less than an hour later, and this time it was for a Starlink mission. The rocket's fairing was packed with 24 Starlink V2 mini satellites, which were all delivered to low Earth orbit. This mission was flown by booster B-1077 on its 17th mission, and it touched down successfully on drone ship Just Read the Instructions. The next space traffic event took place elsewhere in the solar system, as BepiColombo performed its 6th flyby of Mercury this week. BepiColombo is a joint mission between the European Space Agency and the Japan Aerospace Exploration Agency that will eventually deploy 2 spacecraft in orbit around Mercury. These orbiters are currently traveling together, and they performed a series of flybys to get on the right trajectory for it to arrive in orbit around the planet. During these flybys, BepiColombo swung by Mercury, allowing the planet's gravitational pull to change its path. This maneuver is therefore also known as a gravity assist. On January 8th at 5:59 UTC, BepiColombo screamed past Mercury at an altitude of only 295 kilometers above the planet's surface. A few minutes later, it flew directly over the planet's north pole, at which point ESA took the opportunity to point BepiColombo's monitoring cameras, or MCAMs, at the planet. Now, these cameras were never meant for scientific observations, as their purpose was to check whether the spacecraft systems had deployed correctly, but nevertheless, they took some impressive images of Mercury. While passing over the North Pole, MCAM-1 captured an image of some of the coldest places in the solar system, 4 craters called Prokofiev, Kandinsky, Tolkien, and Gordimer. Despite Mercury's close proximity to the Sun, the floors of these craters get no sunlight, as their location at the planet's North Pole means that the crater rims cast a permanent shadow. There might be water ice inside these craters, and that's something that BepiColombo is going to investigate during its mission. The camera took another image 5 minutes later, and this one shows Mercury's volcanic plains. A third image was captured by MCAM-2, and it shows how the planet's surface varies in brightness. Scientists believe that Mercury's surface is slowly becoming darker over time, and this image shows how bright, fresh material is brought to the surface through volcanic activity and large impacts. This flyby was BepiColombo's 6th and final. The next time the spacecraft meets Mercury will be in late 2026, when it will enter orbit around the planet. Both orbiters will start their science missions shortly thereafter, so there's much more to come from the planet closest to the Sun. Back on Earth, we had another Starlink mission. On January 8th, Falcon 9 took to the Floridian skies at 15:27 Universal Time, adding 21 more Starlink satellites to the constellation. Of these, 13 had direct-to-cell capability, and the other 8 were regular Starlink V2 mini satellites. This was the 3rd mission of booster B-1086, which landed successfully on the deck of a shortfall of gravitas. The next mission took place on January 10th. Falcon 9 lifted off from California for the 7th launch of the National Reconnaissance Office's proliferated architecture, also known as Starshield. Some of the previous launches have carried some Starlink satellites as rideshare payloads, but we don't know if that also happened this time. This mission was flown by booster B-1071. It became the 5th booster to fly 22 times and landed successfully on drone ship Of Course I Still Love You. And closing out the week, we had a Starlink mission on January 10th. Falcon 9 lifted off from Space Launch Complex 40 in Florida, bringing 13 Starlink direct-to-cell satellites and 8 normal V2 minis into low Earth orbit. The booster landed successfully on the deck of SpaceX's drone ship Just Read the Instructions. With the 3 Starlink missions this week, SpaceX has now launched a total of 7,698 Starlink satellites. Of these, 765 satellites have re-entered, and 6,227 have moved into their operational orbits. Next week promises to be a very exciting week in spaceflight. Starting off the week, New Glen's maiden flight is currently scheduled for January 12th. We followed Blue Origin's preparations for this important mission in previous episodes, and this week, New Glenn rolled out of its hangar back to the launch pad after it received its Blue Ring payload. The launch was originally scheduled for January 10th, but delayed because of rough seas in the landing zone, approximately 620 kilometers downrange in the Atlantic. While recovering a rocket booster on the very first flight is very ambitious, Blue wants to try anyway and give it a chance of succeeding. The window for New Glen's first flight opens on January 12th at 6 o'clock UTC, and it lasts for 3 hours. If the weather or the rocket don't cooperate for some reason, backup opportunities are available on the following days. On January 13th, we'll have a Starlink mission from Florida. Falcon 9 is set to deliver another batch of direct-to-cell satellites into low Earth orbit. T0 is expected during a roughly 4.5-hour window starting at 14:59 Universal Time. Next week definitely looks to be the week of massive rockets, as Starship is set to fly on its 7th flight test on January 13th. This will be the first flight of Starship Block 2, which is even taller than its predecessor and features many upgrades and redesigns. What's more, SpaceX wants to test if Starship is ready to fly Starlink missions and plans to deploy 10 Starlink simulators while the ship is on its almost but not quite orbital trajectory. The window for this launch is scheduled to open on January 13th at 2200 UTC, with backup windows available in the following days just in case. The next mission is SpaceX's 12th transporter mission. This flight is expected to lift off from California on January 14th, with T0 set during a nearly 1-hour window starting at 1849 UTC. On board are a number of rideshare payloads, and among them is a satellite for YouTuber Mark Rober's company. And if 2 massive rockets weren't exciting enough, we'll also have a mission to the moon next week. Or actually, 2 missions in a single launch. Falcon 9 is set to take off from Florida on January 15th with 2 lunar landers on board. The first passenger is Firefly's first Blue Ghost lander, and the other is the second Hakuto R lander from the Japanese company iSpace. T0 for this mission is expected on January 15th around 6:11 Universal Time. And closing out the week, we'll have a spacewalk on the ISS on January 16th. NASA astronauts Nick Hague and Sunita Williams, yes, one of the Starliner astronauts, I mean, why not, she's up there already, are set to step outside of the station at 12 o'clock UTC. During this extravehicular activity, the astronauts will service 2 science experiments. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.